This session is on scientific notation, and you will notice we have two very unusual numbers. One is extremely large, one is extremely small. Scientific notation works with such numbers. These are numbers, and if we make them into a quantity, which is what science works with, this would be the units. Remember, you have a number and you have a unit. The units would be perhaps particles per mole, and you're going to be studying mole quite a bit. The second one is coulombs per electron. This is a charge of electron. This first number is extremely important in chemistry, and this is sometimes called Avogadro's number, or more recently Avogadro's constant. And Avogadro was a scientist that did some major work around 1811 with the idea equal volumes of gases at the same temperature and pressure have equal numbers of particles. But Avogadro did not come up with Avogadro's number. It's an honorary name. The most noted person is Perrin in 1909, and won the Nobel Prize for his work in 1926 identifying Avogadro's number through several methods. The next story is great because this is the charge of an electron, the fundamental particle, and this was identified by painstaking work with an American scientist at the University of Chicago. His name was Robert Millikan. And Millikan's work was called the oil drop method, and you will be studying that. So here are two numbers, and put with a unit become a quantity. And they are also written this way: 6.02 times 10 to the 23rd particles per mole. And the second one is written as 1.6 times 10 to the minus 19 coulombs per electron. Now, what's the difference between these? This is called a standard notation of a measurement. This is called scientific notation. And here's what you do to go from the standard to the scientific. You find the decimal point, and you make sure that you rewrite the number with one digit, 1, to the left of the decimal point. And then you find out how many powers of 10 you have in a number. One digit to the left of the decimal point. Very important, simple idea. What this does is reduces a large number, a very small number, to a manageable number. And let's take a practical example. Let's take the number 3,500. To make that the scientific notation, you count powers of 10. You go 1, 2, 3, because this number becomes 3.5. There's your one digit to the left of the decimal point, and that's 10 hundredths thousandths. That's 10 to the 3. So you go tenths, hundredths, thousandths. 3.5 times 10 to the 3, and this could be grams, for instance. Or you could have a number such as this, 0.0035 grams. And again, you get one digit to the left of the decimal point, so you count this way, to the right. 1, 2, 3. There's your point. Becomes 3.5. Now you're dealing by tenths, hundredths, and thousandths. 10 to the minus 3 grams. Okay? So if we take this number, 0.0035, and I'll rewrite it up here as 3.5 times 10 to the minus 3 grams. And we'll put what each part is. This part right here is called the coefficient. One digit to the left. The 10 is the base. And the -3 is the exponent. And of course, that grams, that's the unit of the measure. This is the basic factors of any kind of number. Now, another way, a second way of looking at scientific notation is the number has to be, we'll just say an alternative way. The number has to be the coefficient, we'll call it the coefficient, has to be greater than or equal to 1 and less than 10. Greater than or equal to 1 and less than 10. That will give you the same thing. I like to say one digit to the left of the decimal point. I can understand that because I'm simple. Now, let's try another one. 8500000. Okay, let's put that in scientific notation. And you can assume there's a decimal point there, or we'll put it there. You count 1, 2, 3, and I put the numbers in sets of 3. 3, 6, so that becomes equal to 8.5 times 10 to the 6. Now we can use engineering notation if we want to. That's used less frequently, and that's used where you want to substitute a prefixed metric measurement for the power of 10. Let me translate what I just said. Let's say we have a number of 3.7 times 10 to the minus 10 meters. Okay. Now, if I want power sets of 3 here, multiples of 3, let me say it right. If I want to get this to -9, that's the closest to multiples of 3. I take this number and make it a factor of 10 smaller, and this a factor of 10 larger. I get 0.37 times 10 to the minus 9 meters. And if you look here, we have the prefixes. Remember, 10 to the minus 9 meters is a nanometer. So we could just substitute nanometers here, and this becomes 0.37 nanometers. So engineering notation just uses multiples of 3 so we can substitute these prefixes. Okay, I think we'll stop right there, and I would suggest you go back to, or go forward to scientific notation with operations. And that's where I recommend we go next. We'll stop there.